Hello everyone and welcome to the second part of fifth session. In previous part, we have discussed in detail about the first category of resistances, that is the train resistance. In this part, we are going to discuss about the remaining categories. So let's discuss one by one. The second category of the resistances is the track resistance or due to the track profile. It includes the resistances due to the physical features of any track. Mainly it includes two things. Those are, the first one is the gradient and second one is the curves. The resistance due to gradient can be computed very easily with the help of this diagram. You can see the vehicle is moving in a right direction on a track which is having the angle of inclination theta with horizontal. Now the weight component W is acting downward side through a CG, where N is the normal force and the reaction developed is denoted by R. Now here the angle between normal force and the weight component is also theta. So we can write as R is equal to W sin theta. Now in practice the angle theta is very small. So we can replace the sin theta with the tan theta, because tan theta is a known quantity which is nothing but the gradient of the track. So finally we can conclude R is equal to W tan theta. If the value of slope is given in percentage, then the same formula can be written as R is equal to W into slope in percentage divided by 100. The second track resistance is due to the curve. While traversing curves, centrifugal force acting on the train, which causes wheels to move in an outward direction. Now, if you observe the shape of the wheel, at the curves, the outer wheel travels more distance as compared to the inner wheels. And this is nothing but the resistance offered by the curve. Now, this resistance due to the curve can be computed with the help of the formula that is equal to F into G upon R, where F is the force due to the sliding friction, G is the gauge of the track, and R is the degree of curvature. Now we are coming to the another category of the resistances, that is the tractive effort, which includes starting and acceleration. In case of the starting, the values being defined for both locomotives as well as the trailing vehicles as shown here. Now here W1 stands for the weight of the locomotive in tons, while W2 stands for the weight of vehicle, which can be a wagon or a passenger compartment. Now the another case is the resistance due to the acceleration. This resistance can be found out with the help of the given equation. Now here W is the weight of the train in tons, V1 is the initial velocity, V2 is the final velocity, while T is the time required to reach to the speed V2 from V1. Now the last category of the resistances is the wind resistance. It is defined by the various factors actually, like the wind velocity, the direction of the wind, and the relative movement of the train with respect to wind direction. This wind resistance can be computed with the help of the given formula. Here A denotes the exposed area of the train in square meters, while V denotes the wind speed in kilometer per hour. Finally, we can calculate the total resistance for the traction by adding the train resistances, track resistances, wind resistances, and the resistance due to starting and acceleration. I hope through this video I have clearly explained the different resistances to the traction. Thanks for watching.